Welcome to video 4.4a, the equidistance theorem. All right, so I'll go over a few examples and go from there. All right, first we have to define a few terms. The first is perpendicular bisector. So if a line bisects and is perpendicular to a segment, then it is a perpendicular bisector. So here's an example. We'll call that segment AB, and we'll have a line here. We'll call that line L. If line L is perpendicular to AB and line L bisects AB, then line L is called the perpendicular bisector of segment AB. Second term we want to define is equidistant. If a point is equidistant from the endpoints of a segment, then the distances to each point are equal. This is actually an easy concept, but it's just hard to say in words. So here's a picture. So let's call this segment AB, and let's call that point C. If point C is equidistant to those endpoints, then that means the distance AC is the same as the distance BC. So I'll just write that down. If C is equidistant to endpoints A and B, then AC equals BC. And again, if there's no segment bar over there, that means the distance from A to C. All right, so now we're going to go over a little activity. We've got these three black segments with points A and B, and what we're going to do is try to discover a relationship between a segment and a perpendicular bisector. So in blue, from point B, we're going to go to the endpoints of the black segment. And in red, we're going to go to the endpoints of that segment. And if A and B are equidistant to those endpoints, we get a perpendicular bisector. Over here, we got points on opposite sides. A, equidistant to those endpoints. B, equidistant to those endpoints. And then if we connect points A and B, we again get a perpendicular bisector. We could even have a point on the segment. Okay, so A is equidistant to the endpoints. B is equidistant to the endpoints. I'll connect points A and B, and I will obtain the perpendicular bisector. Okay, so the big concept here is, how does AB compare to the black segment? It's the perpendicular bisector. All right, so to get a perpendicular bisector, you must have 2 points that are equidistant to the endpoints of the segment. 2 points that are equidistant to endpoints of the segment. That is the major concept. I'll say it once again. To get a perpendicular bisector, you've got to have 2 points such that they are equidistant to the endpoints of the segment, and then if you connect those 2 points, you will obtain a perpendicular bisector.